Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at some snippet of code that I provided you as part of a series of demonstrations that we're going to call our fundamentals demo. Our hope is that we're going to use these examples to learn more about the C programming language. This assumes a couple of things. Number one, that you've got a working environment to development environment to work with. And secondly, that you have somehow gotten a copy of our integer division.c. Now I'm leaving this up just in case that you don't have a copy of it so that you can go ahead and either take a screen capture or pause the video here and copy in the code that I have provided for you. The first thing that we want to do is we want to go ahead and bring the function prototype over, just like we did in an earlier example. And so you just go ahead and copy the function prototype and you add it to the list of function prototypes at the top of your .c file, in this case our fundamentals.c. The next thing that you want to do is go ahead and copy the implementation, including any comments, to your .c file. So in this case, we're going to go ahead and continue to add these functions at the bottom of our .c file. And so the order in which you add them doesn't really matter. At this point, we no longer need this snips file that I provided, and you can go ahead and close it. There are other ways to go about adding source files, or excuse me, source to your project, but this is probably the simplest. We're going to go ahead and build it. And assuming that you had working C code before, you should also have working C code now. This is a great example of perhaps a colleague providing some code to you that you wish to try in your file. Now, we have so far added the function prototype, we've added the function implementation, but we have in fact done nothing to run the code. And so just like in the earlier example for the arithmetic operators, what we want to do is we want to go ahead and type in the name of the function that we have just added. So in this case, it's going to be integer division, followed by a pair of parentheses and a semicolon. And this is what will actually make a call to our integer division demo. And as in the earlier example, these demos are just simply meant to be a starting point in your exploration of the C programming language. Now, because we don't want to run both of these demos every time we run our executable, what we can do is we can simply comment out any other functions that may be present in our main. We can go ahead and save it and build it. And once again, you should have functioning C code. If you don't, then take a second to see if you can find the error. At this point, what we want to do is we want to go out to our console and we want to go ahead and run our executable. So in this case, I'm going to type in dir and you'll see that I'm already in my fundamentals demo project folder. And specifically, I'm in my distribution debug min-gw Windows folder. And you can see there is my fundamentals demo.exe, which I can simply run by typing in the first few letters and hitting tab. If you hit enter, then you should see this nice table pop up in the console. And what we'd like to do now is we'd like to take a look at the code that generated that output. And so if you scroll back down to your implementation of the integer division, and we're going to take just a second to split the screen so that you can see both the source and the output. So we sort of line up each line in the output, figure out exactly how we got it. So you can ignore my little warning here about not modifying the table. I'm actually encouraging you to do so at this point. The idea behind this is that this table just has a nice table header, as well as some delineation between the table title and the contents of the table. Once again, just to make it look pretty. Now, we begin with a series of printf statements, particularly using the format spec %d. Our whole goal here is to focus just on integer division in this demo. So we're going to do no double precision. Instead, what we're going to do is look at how integer division changes based on the value, but also on the sign. So in this case, what we're going to do is we're simply going to have three %ds. The placeholder indicating an integer. And following that will be then 3 values that will be plugged into those placeholders. So if you've not yet done so, I would encourage you to go take a look at the printf documentation on the Wikibooks, and particularly this table of the format specification. Now, continuing here, what we'd like to do is we'd simply like to divide 3 by 15. And if you'll notice, the results of 3 divided by 15 is in fact going to be 0, because 3 divided by 15, or 1/5, would result in 0.2. However, we are not interested in the decimal value, merely the integer value, or essentially the whole number value. So the rest of the information is essentially lost to us. Now, any value up until, and as a matter of fact, we can just simply go ahead and test this. So if we were to follow up with this, we'll say 3, maybe 4, and 5 will all result in 0. But what would happen, do you suspect, if we typed in something like 8, which is going to be, if we do the division, you'll know will result in a value greater than 0.5. So if we build this real quick, and we hit our arrow, you'll notice that I didn't change it here. Sorry, let's go back real quick. 4, 5, and 8. You can't just simply change the value here. You actually have to change it in the calculation as well. Let's go ahead and rebuild it. All right, so if you notice here, 3 divided by 15 is 0, 4 divided by 15 is 0, 5 divided by 15 is 0, and 8 divided by 15 is still 0. As a matter of fact, if we were to do everything up to 14 divided by 0, I'm going to go ahead and build this and run it. You'll notice that even 14 divided by 15 is going to be 0. So essentially what you're seeing is that we are losing any data after the decimal point. So essentially what happens here is we are truncating the results for these. So first ones here are going to be truncating the decimal value. And once again, this shows you how I'm encouraging you to sort of play around with this table, test for yourself how you see to see how things work. Notice the same thing here when I do 15 divided by 3, 16 divided by 3, and 17 divided by 3, I get 5 for all of the values. It is not until I have 18 divided by 3, which would of course return the whole number of 6, that I get 6 as a result. But what happens if I do negative examples? In other words, if either the numerator or the denominator is negative, does that change the behavior any? Well, in this case, what we're going to do is we're going to do 16 divided by -3, and you'll see that the return value is going to be -5. That's not too terribly surprising. Also, if you do -16 divided by 3, the return value is going to be -5. And then -16 divided by -3 is going to be a +5. This next set here deals with division when 0 is involved in the numerator. So in this particular case, you'll notice that I am dividing 0 by 4. Now we would expect that the answer would be 0, and in fact, it is. But what happens if we have 0 in the denominator? And we know that we can't do this in our algebra class. We learned that that is supposed to be infinity, but we really don't have a way of handling that in our C programming language. And it is not like in MATLAB where it's smart enough to determine that we're doing infinity and return back a specific value of INF. In this case, though, if we go ahead and build this, when we've uncommented out that code, we will get a warning that says that we are attempting to divide by 0. But let's say we ignore that warning, or maybe the value is provided at runtime by either the user or some other code in our executable. What happens? Well, you can tell by the timestamp, in other words, if I type in dir, that we did in fact get a new executable. In other words, you see that it's 231 and the time on my system is 231. So it did actually build the executable. But what happens if we try to run it? Well, if I run this, you'll get all the way down to the offending line of code, and then the executable crashes. Depending on which operating system you're on, you may get some additional warnings, but at the very least, you know there's a problem because there was that delay, and then it simply returned back the command prompt. Now, at this point, you'll also notice that that second bar there, that second delimiter for our table, wasn't printed. So essentially what happens is your executable crashed at the point where you attempted to divide by 0. So at this point, what I would suggest that you do is to go ahead and comment this code back out and just make a note that when you divide by 0, you will crash your executable. Hence, it's very important to make sure and do error checking specifically on the denominator of any calculation that involves division. So once again, let's go ahead and build it and run it, and you'll see we're once again back to working code. So it's important to note that integer division is a little bit different than dealing with division or double division, and that essentially what it does is it truncates the value. Hopefully you found this video useful. As always, don't hesitate to let me know if you have any questions or comments, and thank you for watching.